Good morning. I decided to do a video on an oscilloscope I've actually purchased. I haven't actually used oscilloscopes for probably over 40 years, but as I've got a couple of old computers to repair, especially well, this old ZX81 for a start, once I get a replacement ROM, which I have no idea what ever happened to it, although looking at the soldering, this would be another video anyway, but I was looking at soldering. I think at some point this actually had a character ROM little board attached to it, and I have a vague suspicion that the ROM went onto this little character board, which was then like I say, soldered onto the CPU and possibly a couple of other places, but I think this is my actual original ZX81. So that ROM probably still ended up on that board. God knows whatever happened to it. So I don't know. But anyway, I've ordered another ROM for this, but I'll do that one in future. So I thought I'd get another oscilloscope. I'll get an oscilloscope because I've noticed that a lot of people use them. It might be handy in repairing things. So I've done a quick bit of research. Didn't want to spend a huge amount of money, but didn't want to do what was the cheapest thing on the market. So this is, yep, paid about £250 sterling direct from a distributor of these. It's Chinese made, I believe. Had it. Ooh, it's, magazine of stuff. They said, oh, that could come in handy. I'll have to have a look through this to find out. There might be some other interesting things. So, don't know much about oscilloscopes. I know there's digital oscilloscopes, and know there's press play. Oh, British. I know there's analog ones, digital ones. But I thought I'd go for a digital one. This doesn't actually have a HDMI output, I don't think. Or does it? Oh, actually, there's a little picture of one. Well, I'll have a look. So I might be able to do something about recording some stuff directly to this, but I'll come back to that in a minute. Use guide. So looks like I've got a couple of little packets of probes and some little coloured bands. I have no idea what they're for, but I guess voyage of discovery. More power. Oh, that's interesting. Oh, sorry. Just realised that's actually got a Euro adapter on the end of it. So rather than supply specific ones, we other way around. We looks like we do make it slightly cheaper. So Euro cable, no use for that, so that can go in the stock or stick it into recycling. And what we'll do is let's just take this out, get in the box, more boxes. Oh, there is. Okay, there's a USB cable. Don't know what that's for, but we're sure to find out. So let's have a look. Little phone. Find out. Hopefully this is recyclable, but I'll find out. Never mind. Okay, so this is actually a little bit. It's a plastic gel thing. It. Okay, so this is a little bit bigger than I thought. Got lots of buttons, cursors, acquire. So I was just reading. So we've got cursors, acquire, save, measure, clear sweeps, utility, history, decode, default, display, persist, auto setup. That's probably going to be handy. Run, stop. So I guess that's probably a freezy bits. I guess we've got some vertical axis stuff, which is zoom bits. Maths rest roll. Oh, there's a zoom thingy there. 0, oh, X input, Y input, external. Oh, okay. So yeah, this one didn't have a HDMI output. Obviously, that was just one of the other models they're doing. So I just went for the cheaper one without HDMI, which I may come to regret, but no doubt will come. Perhaps that might be just get a camera to actually take some images of that. So what we got? Little carry handle. Actually, what is on the back? Oh, there's a network connection. I wasn't expecting that. And USB device. I think it says calibrated. I wonder what that's for. To be honest, I had a quick look around for reviews. I didn't pay much. Otherwise I spend hours and hours looking at things, but didn't really want to do that. Oh, little lock thing on the back as well. Okay, that's cool. Let's just have a quick flip through the start guide. It's a bit of paper. What's the bit of paper? Oh, it's talking about certificates of calibration. So that's interesting. Digital signature. So obviously this was made in China. So look at a quick start guide. A lot of times I'll plug things in, but probably I'm going to do that. Oh, okay. So we've got adjustable feet. So this is just a 2-channel scope. So I didn't think I'd need to do much more than that at the moment. So we've got power socket, adjustments. There's a power. Oh, power to the left outside. Some stuff about compensation signal. That means ground terminals. Some self-tests and some other bits. Some other bits here for connections. This is a 2-channel scope. So user interface, some things. Analog channel, USB host. Don't know what that means. I wonder if it does send some stuff out to a host. I'll find out. Handles. Oh. Remote control via a LAN interface. Find what it does. And some USB remote control stuff. We've got some other bits to do with rolls, some triggers. I have absolutely no idea what any of this stuff means at the moment. So this should be a voyage of discovery. Oh, okay, so the vertical scales, so you can set a vertical position and a vertical scale, so I guess that's going to be how big it displays a waveform on the screen. So I have an auto setup for the screen and a button to do a state. Okay, let's interesting, so let's just see what that does. Okay, security lock. What was that on the back again? Number 4. Pass, fail, or trig output. Those interfaces, the oscilloscope can output a signal that can reflect the current capture rate of the instrument at each trigger or a pass-fail pulse. I have no idea what we actually use that for, but okay. So I assume I'll plug it in. Let's have a look. Over there for a second. What do we have in here? Oscilloscope probe. That was actually in this one. And another oscilloscope probe. 1x and 10x. I have no idea what that means. And there's some coloured rings. Let's break into this. Well, not break into it. Tear apart. Let's just see what we've got. So, something. Oh, okay. So I've got the end cover of probe there. Oops. So, guess. Is that fixed on? Oh, okay. So there's a little hook thing. So I guess if you want to fix something to one side, whoops, where's it gone? Got this little crocodile clip thing, so I guess you can clip on. Oh, is it not working? I guess you can clip on. Oh, there we go. So I guess you can actually clip onto something with a probe on one side. So I guess you can use one as an earth lead. Okay, so it says it'll do up to 2 megahertz, which I guess is enough. What I need to do. So at the moment, I don't really want to spend huge amounts of money. I don't know why I've got coloured rings. I don't know what that is for. Let's have a look. Oh, it's a little. You'll see it. I wasn't getting this. Get it to zoom in properly. So we've got a flat edge. Ah, there we go. There's a little flat edge probe here. So okay, so we can actually replace the something. Don't know what it's for though, because that seems to be one fixed bit of plastic. So I don't know what that's for, but no doubt shall find out. Accessories. Okay. So provided with several accessories. Where's that flat one? Probe compensation adjustment. Use the adjustment tool for probe compensation adjustments. Ground springs, locating sleeve. BNC adapter. Realize the mutual conversion of signal. Don't know what that means. Marker rings to match colour rings onto the probe cable and shaft to identify different signals. Okay, still got no idea what that means. So never mind. We'll come back to that. Well, I guess if you're doing a couple of different things, and oh, okay, so you've got a couple of coloured rings here, so you can actually just change, so you know which ones are which. I guess plugged into what side. That's fair enough. Okay, so always like to turn things on, see what it does. Let's have a quick check what this says about turning it on. Connect to AC power supply. Okay, whoops. Let's actually have a USB. Let's just get the UK power cable. So the protective bit off. Let's just shift that back there. What to do? What's this? Okay. Got little feet. Okay, little feet. Oops. That's cool. Need more cameras. Okay. Oops. I guess for the moment, let's take a bit of foam here for a sec, so I can actually not scratch my desk so much. And we can just plug it in, have a view what it does. I assume it's the position of this is not going to make any difference, so that's power. Let's make sure. Connect to power supply. User called, yada yada yada, blah blah blah, power socket. When the scope is energized, turn on the power switch. You mean after you've plugged the power cable in? Okay. Let's turn it on. Ooh, things light up. So this is a Siglent. I guess it's Siglent. So let's see what it does. So it made a little click. Oh, we have a beep, another click, another display, and we have a grid. Cool. Right, what do we do now? Yada yada yada. Provides passive probe. Please respond to the corresponding probe user guide. Connect the probe. Connect the BNC terminal of the probe to one of the channel BNC connectors. Okay. So let's get a probe. The probe is just take off that little bit for a moment. So, okay, that's one plugged in. Connect the probe tip to the circuit pointer test and the ground alligator clip of the probe to the ground terminal of the circuit. Yeah, I might possibly need a circuit to do that. Okay. Just going to pause here because what I'm probably going to do is, I was thinking about this when I bought this, is before I mess with trying to test other things like I've lost it already. This is a mess. Before I test things like this, I should really find something to test it with. So what I'm going to do is, where's it gone? I have a box of bits. So what we're probably going to do, okay, so I've got 3 volts of bits. I was going to take the breadboard thing, and what I was going to try and do is look up a little sine wave generator circuit. I was looking at this the other day, so I was just going to create a sine wave generator with a breadboard. I might have another one of these breadboards around, so I don't have to pull these little things out. I know there's time. I've got some timing chips or something, which means we can make things adjustable. But for the moment, I think let's try and do a very basic circuit. So I'm just going to pause this here, whilst I go investigate where I've left a mess of things to do. Right, pause, pause, pause. Where's pause? There. Okay, so a little bit of hunting around. Got this little storage box. Storage box? What am I talking about? I found this breadboard, which is part of a sort of electronics kit for a Raspberry Pi to actually test some stuff, which I think I mentioned just before I paused it. So what I'm going to do is I've got. I was looking to find how it's powered, but it looks like we've got a little power thing, and I wanted to check. We've got plus. So if I have a quick check, I know I've got a valid battery here. Oops. Oops. Bugger. So yeah, just over 9 volts there. But what I wanted to do, because I don't want to waste batteries for no real reason, so there's a little adapter thing that came in the kit to actually do 9 volts. So what I'm just going to do is check to see whether this is sensor negative or not. Oh. So if I can actually get this. Okay, so this looks to be based on the which way round is this? Trying to work out whether this is okay. This looks like to be sensor negative based on the display there. Oops. Which showed, put the red lead in the middle. Come on. I've got small probes on here. Oh, damn it. Yeah, so that shows that I believe this is sensor positive. So what I've actually got, let's just take that off for a second. So what I should have, it's not really in front of me. I've got a little 9 volts converter which is for ZX81, so this was this sort of ZX81 at the moment, but what I should have is a little adapter box so that I can tip. So it's got in here, it just says, oops, can't see it too well, if we can get the focus, nope, nearly. Anyway, it says tip there, and it says positive one side, negative the other. So what I should be able to do is tip positive. Let's try that way around. So I should just plug this in. So hopefully this will show. Oh no, that's one way round. Let's check it the other way in. So hopefully that should show. Oops. Yep. So that should show the centre is positive and the outside is negative. So that's cool. So which means I should be able to power this little box with, or this little breadboard, just using a mains power supply. So let's just Let's just put that there for a sec. So what I'm just going to do is remove all the components from here just to leave the minimal bits. Let's pause. Okay, finally, after a bit of work, I've extracted all the chips and other bits which came with this, which also I've never used them. I've actually got round to using it for the moment, so we'll do that. So what I should do is take our little 9-volt, plug it in, and hopefully there's not an off switch here. Hopefully that should mean a little green light, so I guess that's good. So hopefully it should mean if I can get this, where's, oh, that's gone. Don't know whether these are enough to go down to the probe, so we should have. Nope. Okay, let's find a couple of wires. Somewhere here. Oh, got a little bunch of wires here. Let's just get two. I can grab two out. Where is the knife? Just do that. Oops. Let's get black and a red. Whoops. God, some of these are long. That'll do. Black and a red. Or actually, as the colours are on there, let's go for blue and red. Nope, that's still black. What the hell? Oops, that's long. Where's that short one I had? I had a short one a moment ago. Oh, there we go. It's red. Okay, so stick. Come on, here we go. That's red, that'll do. So I should have some voltage here. Okay, 3.3 volts, that's fine. So I think what we've got here is, that's fine. There's a little adapter bit here that basically says voltage. So I guess on the other route on this side, seems to be marked the other way round. So we should have 3 volts on that side as well. Cool, or just 3.3 volts, which is fine. So I'm just going to use some basic circuits. What is that? Did I accidentally just slice through something? No idea, doesn't matter. Yeah, so now that I've got some power, oh, actually, that's interesting. So I could do, so this little board thing I've got here, so it looks like I can do 3.3 volts or 5 volts on one side, and there's a little jumper to do 3.3 volts or 5 volts on the other side. So you can have 3.3 on one side and 5 on the other. So that's quite handy. Right, let's just pause this as get time to get a little bit of a lunch or something to eat soon. Or well, yeah, might go grab something to eat, and then what I'll do is come back and see if I can work out how to create a little sine wave circuit, which I've done a bit of research. I found some stuff on. I say I really do not have much of a clue about electronics as I haven't touched it for ages. There are no components, but I don't know too much about how circuitry works anymore, because the last time I done it was, as I said, over 40 years ago in school. Right, let's just pause that for the moment, or stop it for the moment, and then I'll create another video. I'll attach another video to this. Okay, so going to carry on with this video now. It's about 2 weeks since I started the video. I can't quite remember what I've done in the first bit, which we've just seen, but got an oscilloscope, just want to test it. So to that end, I had a look around. I've created a little sine wave circuit. Not quite sure how it works, but if I go to the window, which isn't actually showing, why is it actually not showing? Let me pause this a second. Well, helps if I pick the right window. Okay, so I found a little circuit which creates a sine wave. This isn't going to go well, I know this already, because of a couple of things. First bit being that this requires a 9 volts, but I don't have a 9 volt power input at the moment. Probably could fashion one actually, but we'll come back to that if this doesn't work. So anyway, got a circuit here which generates a sine wave. Don't know the frequency, don't know anything much about it, except there's some resistors, some capacitors, that's what I was looking for. There is a resistor, some more capacitors. There seems to be a resistor going off to 9 volts, which is 2k resistor, and then there's some kind of output capacitor that does something. So you can see the breadboard circuits at the bottom. Bought some components to test this with, but I'm not quite sure how well it's going to go. Just switch back to the webcam. So with other bits and things I've found, I bought some components, just a mixture of things, but what I've actually got here, this actually zooms in, I guess to zoom in, not zoom in, that's not the word, focus, that's the word. Still need a better camera at some point, or be able to fix the focus range. Oh, that's not great. Anyway, so I've got some, I think 1k resistors here. So pretty much this follows the diagram which I just showed. I could have actually merged this together. So anyway, so we've got resistors, got the capacitors, of which I think are correct, and there's a couple of little bridging bits here which sort of follow that circuit. Let's go back to the diagram. So this pretty much follows this diagram here, with the difference that I don't have 9 volts, I've got 5 volts. So got a little thing, it came with a kit I bought when I was learning about some Pico stuff, which I still haven't finished or started properly yet. But this takes 9 volts in, but it converts to, this doesn't really show it too well. Can I zoom in? No, we're not going to, oh, no, we are going to focus. Oh, do we focus a bit? So we've got a couple of jumpers for 9 volts and 3.3 volts. So we take a 9 volt in and do 5 or 3 out. So what I've actually done is I've taken this. I'm going to do 5 volts. So, to be honest, I just want to see if it actually records something on the on the oscilloscope, to be honest, which is the whole purpose. If it's not great sine wave or whatever, I just want to see if this works. So then once I've done that, I can then go on to things like fixing a couple of computers. For this X81, which I know I mentioned before, I've actually got a ROM for it, which I bought off a company that basically made it for me, which was So I've basically got the this hopefully is x81 ROM here, so once I've got composite mod done, I can actually use this oscilloscope to test things and also to repair Commodore 64 and sound on the ZX Spectrum I've got. So which was the whole purpose of this, and play around with toys. So what I do need is 9 volts, or 5 volts even. And what did I do with the adapter? I'll probably put on the floor here somewhere. Oh, that was it. Okay. So for the ZX81, because I didn't have working power supply, I bought this adapter thing a while back, which allows multiple voltages and allows you to do center 9 volts or the outer sleeve 9 volts, depending which way round you got it. There's a couple of plus minuses, so you can just turn it round and then it switches. So what we've got then is you've got a little 9 volts, got a little on off switch, so I'll do that in a second. So I just want to see if this does something. So you're not going to break anything because I haven't actually got enough voltage. So we've got a probe. What we've got? So I believe this is a dual channel, I think. X and Y axis, I don't know. No idea. Trying to actually remember now. Do X, Y, or do I do X? EXT. I thought EXT was the ground. Bear me a second, I just need to pause this for a second. Right, downloaded the manuals. Okay, so it seems I haven't been through the setup bit properly yet. Probably should have read the manual bit. But hey, why read the manual? So according to this, there's a power on inspection, blah blah blah, press the power, yada yada yada, self-test, some relays. Says connect the BNC terminal of the probe to a channel BNC connector, which I guess is this. Oh, if I've got the right one. Oh, actually, too many things plugged in here. Let's just remove this for a sec. So I know what I'm doing. Cables everywhere. Joys. Okay. Let's go back to our tip. So we've got BNC connected. So it says connect terminal to a channel BNC. On the front panel, connect the probe tip to the circuit point to be testing. Connect the ground alligator clip. Oh, that must be the ground alligator clip. I did wonder what that was. I thought it. So okay. Let's remove that. So we've got a tip. So what we've got: connect the probe tip to a circuit point, yada yada yada, and then press the default button to restore conversation. Default. Where's the default button? Is there a default button somewhere? Oh, default. Okay, so we've pressed the default button. So accordingly, so we've got some testing things here. I didn't realise wondered what these were. So we've got, so it looks like it will generate a signal itself to do testing, I guess, or where you set it up to do stuff. So I would assume then that we connect. That'll be the earth. So I guess that's the end of the crocodile clip. I didn't realise that there's actually a couple of wires on here. I think this has got a 1x and 10x. Can't actually quite see. Oh, yep, there's a 1x there and 10 times. I don't know what that means. but I'm sure we found out. So, and it's anyway. So connect the ground terminal under the probe. Use a probe to connect the input terminal of channel 1 of the oscilloscope and the computation signal output terminal of the probe. So I guess that is this. Oh, it's actually done something. And it says press auto setup. Ooh, it actually showed something. Oh, that's cool. So we've got some funky lines. Will that rest there? Yeah. Observe the waveform on display. It should be a square wave. That's not looking very square. When the probes are used for the first time, you should compensate the probes to match the input channels of the oscilloscope. Non-compensated or poorly compensated probe may cause measurement inaccuracy, blah, 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 blah. Set the switch to 10 times on the probe. Let's actually have a look at the other one. So assume, there's so much light here. It's not. Yeah, so it's so to the left is 1, oops, to the right is 10. Don't know what it does. So perform steps 1 to 3 of function inspection. So I think that's what I was just doing. The probe, blah blah blah. Check the waveforms. So this should be a square wave. Use a non-metallic driver to adjust the low frequency compensation adjustment hole on the probe until the waveform displayed is perfectly aligned. What? A non-metallic driver? I mean, a screwdriver? Low frequency compensation adjustment hole. What? What low frequency adjustment hole? I have no idea what that means. Let me pause this for a second. Right, after that, this will pause. So, it seems it's talking about an adjustment on the probe. So there is, where's the other one gone? So it looks like there's this tiny little hole here. Now what was, it says non-metallic driver. So I did actually find this in the bag, so I'm not quite sure what this is, but it does seem to have something on it, so I'd assume that might be it. Well, it does seem to have a metal bit at the end. It does allow you to twiddle things. So I'd assume, where's that hole gone? Oops. Let's just put that back there. Oops. Somewhere. Oh yeah. There you go. Let's square that off. Okay, so that's good. So perfectly compensated. So yeah, so it should be square wave. So what we've got, we have our square wave. Just realised the angle I was looking at this at, all I could see was a little top bits because obviously this is facing downwards on the camera, and where I'm looking at it, I'm just sort of looking at a 45-degree angle. Okay, that makes sense. Oh, okay, that's cool. So says to do it with the I guess we'll do it on the other one as well. I guess we pointed to. Oops. How do we turn this off? Don't know about that. There's some wiggly lines there. Don't know why it's doing that. Oops. How do we turn that off? Leave channel 2 for the moment. Okay, but what I should do is let's just grab the other probe. So we'll take that one off, take that off, take that off, and let's do the other one. Okay, so oops. So we want a little crocodile clip. Come on, where's it gone? Where's the end of it? Lost it. Ah, there we go. That's weird. Ooh, touch my hand. Oh, funky. That's weird. Right. So, got the hole facing there. So again, that's slightly off. So we'll take our little twiddly stick. Oops, wrong way. So that should be, oops, slightly off. No. Nearly. Ah, no. Missed it. Slight bit. Come on, come on, come on, come on. Nope, still got a little bit on the end. Oh, this one seems to be slightly more fiddly. Okay, that looks square. Oh, cool. Well, whilst we're at it, might as well just leave that one on here. Okay, so we've done our little 10 times function inspection. We've got some twiddly knobs here. What does that do? Oops. Oh, there seems to be a voltage. Let's have a look at this twiddly knob here. Oh, that does something. Any volts? I was going to push this. Oh, disappears. Oh, it seems to say probe 1 times there. Should I dare push this? Oh, okay. How would you select something? Okay, so that's a 1-time view. Oh, okay. How do you come out of this? Oh, menu on off. Oh, no, I just turned off the menu. No zoom things on this. Okay, quick look at display, what we've got. LCD, a universal knob. I'm not even quite sure what that's. Oh, that didn't do anything. Common function menus. What was that, number 3? Okay, that's over here. So we've got require, blah 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 blah. Anyway, got some bits and pieces. Fine, run, stop. Okay, that's fine. Whatever. Where's my other manual? That's the one I was looking at. So I can set horizontal, vertical, whatever that means. No idea what that means. In the setup we can do stuff. I have absolutely no idea. Okay, I think for the moment there's an auto setup here, which I guess means we can auto set stuff up. So I'd assume I was going to do that. So one last check, and how-to guides, probably not the best way of doing this. Suddenly got lots of buttons and things to do things. Actually, it's just page. So we've got some bandwidth limits, don't know what that does. Set some things up. Don't know what that does. So I guess we've got let's read some of these things. Anyway, whatever, let's just see if we can get it to do something. Lots of things. No, okay. Let's just get to try and do something. So I'll assume as we've got a ground and an earth point. So according to this circuit, let's just change. Where's my view of the window I had? So according to this, we have a ground point over here. So I should be able to do from the ground point here, and then our sine wave off of here. So let's go back to our webcam. So I assume then what we should be able to do is do ground point there, so that's our ground line, and then what we also should be able to do then is have our point we're measuring here, so it'd be that. So it shouldn't show anything really much at the moment. I should expect it to. So oops, wires everywhere. Let's just have that there for a sec. Right, so if I turn this on, something may be going on, who's to know? And then I should be able to touch the end of this. Oh, wavy lines. Okay, so it does something. Let's see if we can do I just oh, that's weird. was a wavy line when I touched it. Oh, there's a wavy line. So there is a sine wave, so let us see, how do we do this? A crocodile clip on the end here, really. Actually, saying that, can I? Enough to get it? No, it's not. So there's our wavy line. Seeing if I can. Ah. What's that going to do off the back of this? Oh, God knows. Okay. Let's try pressing auto. Let me just pause this a second. Right, I've just got the user guide up. Actually, might as well show this. So we've done our testing bits. Trigger control. Bottom 5, auto setup. So I was rather hoping that it would automatically. Okay, so if I press auto, it should do what I was actually after. So let's just go back to our view. So I should do something. Oh, this is fun. Wee, funky. What's doing there? So our sine wave. Sure. So it should be doing something. It does allow me to. Okay, so it's just told me. Okay. So we were doing something, but we don't seem to be doing something now, which is interesting. Well, nothing's let out magic smoke, so I assume things are actually working. I'll change this. Oh, There's lots of zooms. How do I go back up? Let's go back to that one time, see if that does anything. Interesting. Not quite sure why it's doing that. Make sure no weirdness is happening. Let's just go back to our test. So this just gives us a square wave. Yep. Okay, so that's fine. That's why this isn't doing, again, like I say, 9 volts. Sorry, 5 volts. Come on. So it's showing something, but again, zoom levels. Who knows at the moment? Okay, just going to test something. Let's just pause this for a moment. Whilst I was just working this out, it's just dawned on me, because of my viewing angle, I couldn't quite see this right. There is actually something going on here. So there is something being displayed. So I haven't actually made any changes. I was just testing stuff out with a voltmeter, so just testing that there was 5 volts going around. But yeah, there is actually something there. So not. Oops. Don't know how we zoom. I'm trying to stretch this a bit. Oop, okay, so that gets us our vertical. Ah, okay. So this actually, let's just move this up a bit. Oh, okay. Oops. I think from looking at the circuit diagram for this, it said it does create quite a nasty sine wave. Oops, I just compressed it in. So it's not really much of a sine wave. Okay, so it does actually do something. So yeah, okay, so it's 5 volts. I haven't, where's that diagram gone? That one. Oops, not that one. That one. Okay, so what are we doing here? Okay, there's actually a video that actually shows it working. It's a much more extensive circuit I had. So it says the frequency should be about 1 kilohertz. Am I guessing from the circuits I had what this was going to do? quite sure how we showed it. Frequency. So according to this, it's, somebody's comment was 102 megahertz. Not quite sure what the frequency it says here is. Does this think about, oops, 98 millivolts. 50 millivolts there. Just changing this. Oh, okay, that was 10 times at 1 times. Something moving along a lot. Okay, so is that sample rates? Let's see. Okay, so something is, well, something does something with 5 volts. Not quite sure what we are seeing. But still, it does actually do something. I don't know what that does. That just shows us that line. Yeah, okay. So it does work. I'll have to see if we can get a better sine wave out of this, but well, anyway, I'm just starting to ramble now. But it does work. We'll see if we can find another circuit at some point, and then we'll do another little test, or see if I can get 9 volts into this, and then see if it improves a bit. But according to a couple of bits I've been reading, yeah, okay, I think that'll do for the moment. It works. It should be a sine wave. It's a bit of a mess. I'll see if I can find out how to clean it up a bit, and then go on to the next step, which see if we can get an adjustable sine wave, so I can test this a bit more, so I can work out how to use an oscilloscope, and then we can go on to the next step. Okay, thanks for watching.